Hey everybody, welcome back to Chem 300. We're going to be starting chapter 2 today, which is all about measurement and problem solving. So a quick overview of what we're going to be talking about in chapter 2. This is kind of a summary of everything. It's divided into roughly 3 parts. So we're going to spend 3 lecture days on it. So this is day 1, talking about taking measurements, scientific notation, significant figures, and how to use sig figs in calculations. We're going to spend another day talking about units and how to do unit conversions. And then we're going to spend a third day using our unit conversions and our sig figs together along with scientific notation to solve multi-step conversion problems with units raised to a power like centimeters squared and cubic inches and those sorts of things, as well as density. So that's day 3. So this will span 3 lecture days. The videos will be divided up into 3 sections. Make sure you watch each section before coming to class. Okay, so let's start off first talking about measurements. So I want to start off with talking about 11 examples why measurements are important in everyday life and why we care so much about them. So if you need to take the proper amount of medicine, that involves a measurement. Cooking properly, right? Cups, teaspoons, tablespoons, grams of substance, cooking temperatures, those are all measurements. Purchasing clothes, knowing what size to purchase, playing sports, whether it's timing or scoring or the lengths of fields and rinks and that sort of thing. Making estimates saying, hey, I think I'm going to be there in about 5 minutes. That's taking a measurement, distance and time, and then making an estimate based on that measurement. Keeping yourself warm or cool. That takes thinking about what temperature it is, which is a measurement, and then making a judgment about if you need to put on a sweater or not based on that measurement. Understanding weight, the proper use of capacity, estimating volumes, how much of something you have, telling time, transportation, the distances between things, and then of course, engineering, buildings, and structures. So measurements are all around us. They're all part of our everyday lives. Every day you're incorporating some sorts of measurements into what you do. And in this class, we're going to do that pretty much every single class, which is why chapter 2 is so important moving forward to understand these concepts, especially when we get to sig figs. Because once we introduce sig figs in this class, every single answer you submit needs to be reported with the correct number of sig figs. So let's just first talk about kind of what a measurement is. A measurement is a technique in which the quantities of matter, how much stuff you have, is determined by comparing it to a standard or a measuring device. And measurements have been around for thousands and thousands of years, right? We've always had ways to kind of quantify how much stuff we have, what we're measuring. The ancient Egyptians used things like cubits, hands, foot, and paces when building the pyramids. And these were based on the standards of size related to the human body. We have measuring devices now that are much more precise than that, but this is kind of where it all started out, using some sort of standard like the width of your hand or the length of your foot, and then using that as the basis of a certain amount of measurement or a quantity of substance. Measurements are always going to have 2 parts. So make sure every time you're reporting a measurement, it includes both parts. It's going to have a number part. That's how much stuff there is, the quantity. And it's going to have a unit. That's what describes what's being measured. So for example, 2 feet. This is the quantity. And then feet is the unit. So make sure every single measurement you report includes the quantity part, and it also has to include the unit part. If it doesn't have a unit, it's like, what are we talking about? 2 feet, 2 stinky socks, 2 jelly beans, 2 donuts, 2 atoms? We have no idea. And so it's really important that when you're doing your calculations, and especially in your homework to get full credit, that you report every single measurement with its associated unit. So continuing our discussion about the importance of measurements, I don't know if any of you have seen this movie kind of made in the, I think like the early 90s, late 80s called Spinal Tap. It's a Mel Brooks movie. So if you've seen like The Princess Bride or Spaceballs, it's kind of one of those type of comedies. There's this classic scene where this rock band called Spinal Tap wants to make a Stonehenge scene to have on stage with them as they're rocking out. They want it to be kind of ancient and mystical and a little bit, spooky with smoke and pyrotechnics coming out of Stonehenge. So they come up with this idea while they're kind of hanging out in their hotel room. And this is the drawing they come up with to give to their stage manager. They said, okay, make a Stonehenge. It's going to be awesome. We want it to be lowered on stage and, you know, flame shooting out of it and all this stuff. So check out this drawing. What units are they using here? They have 18, and then this symbol represents inches. So they made a big mistake for what they were going for. And in the movie, there's this scene where they come up with this drawing, they give it to their stage manager, and he's like, yeah, we got this, you know, no problem. And then they go on stage, and this little teeny tiny 18-inch Stonehenge comes down out of the ceiling, and it's just a big joke. So units are really important. This should have been 18 feet, not 18 inches for them to get it right. Another example, a little bit more serious, is that in the late 90s, the NASA's Mars Climate Orbiter was completely destroyed while it was approaching orbit around Mars. And this was due to a units mistake. So when NASA built the orbiter, they programmed it using metric units for the approach force. So they programmed it using units of newtons seconds. But then the ground-based computer program that was sending it the data it needed to do its approach was sending it data in units of pounds seconds. So the units didn't match. And so because it was sending it numbers in the wrong units, it was sending it the wrong numbers, and it completely burned up as it was approaching the orbit. Millions and millions and millions of dollars lost and research lost, really disappointing because of a units mistake. So units are absolutely essential when taking measurements. Always include your units and check that they're the right units. So here's some common measurements we use in chemistry. We measure mass. We typically use a balance to measure mass. They can look like this. This is called a top loading balance, or they might have like a glass case around them. That would be called an analytical balance. We measure volumes all the time. We'll get practice with this in lab. We use graduated cylinders, typically to measure volumes, or different types of flasks or volumetric pipettes. Length, we typically measure with a ruler or tape measure. Temperature, we measure with a thermometer. Pressure, we measure with a barometer. And time, we measure with a stopwatch. So these are all the different types of measurements you'll be taking in the lab when we get back into labs. There's two common measurement systems that are used today: the English or imperial system and the metric system. So you might be most familiar with the English system. It's what we use mostly here in the United States. We have inches, feet, miles and acres for length and distance, pounds and tons and ounces for weight, quarts and gallons and cups and teaspoons for volume, and typically Fahrenheit for temperature. In the metric system, the common units are meters for length, liters for volume, grams for mass, Celsius and Kelvin for temperature, and atmospheres, which is abbreviated ATM, bars or torrs for pressure. So science, we're going to be using the metric system. We'll talk a little bit more about that when we get to talking about the different units of measurement, but I just wanted to introduce these two systems here. You might be most familiar with the English system. In this class, you'll become very familiar with the metric system because it's what's used in science. Okay, so I'm going to pause it here. Our next section is going to be on scientific notation. Thanks.